there, it's Judy here again, and today we're going to perform another lab, another titration, and in this case we're looking at determining the salinity content. So we determine salinity by using a Moore titration, and a Moore titration is a titration with silver nitrate. So we have silver nitrate in our burette, and the Moore titration works by the halides in the sample that we're titrating will react with the silver nitrate, and the product will be silver chloride. And silver chloride is a solid, so it precipitates out of the reaction, and we get a solid forming in our reaction flask. The indicator that we're going to use in this lab is potassium chromate, and you can see that there's a yellow color to the potassium chromate, and we know we have reached the end point because the yellow color of the chromate will begin to disappear, and we'll be left with the reddish color of the silver chloride precipitate. So we're going to start, first of all, by standardizing our silver nitrate solution. So we have a silver nitrate solution here. It's 0.16 molar, but we want a more precise determination of the molarity of the silver nitrate. So we're going to start by standardizing the silver nitrate. So we're going to do that by doing a titration between the silver nitrate and 3 accurately known weights of sodium chloride. So I have some pure sodium chloride here. So that's going to be used for our standardization procedure. So we're going to weigh out a sample of sodium chloride. I've already weighed one out here. It's 0.21 grams. So you want your sample to be somewhere between 0.20 and 0.25. So I'm going to put that in my reaction flask. And to that, I'm going to add 50 milliliters of distilled water. So I'm just going to rinse out my weigh boat with the water and then pour that into the flask. So this is basically just a salt water solution of known concentration that we can use to standardize the silver nitrate. Okay, so that's our sodium chloride and water. We just want to make sure that's all dissolved. So just give it a little shake. Salt dissolves in water fairly readily, so it doesn't take much to make it dissolve. Okay, that's done. Now I'm going to add my indicator. As I mentioned, the indicator is potassium chromate, so I'm going to add 2 milliliters using an Eppendorf pipette. That's 1. 2 milliliters of the potassium chromate indicator. So, as I mentioned in the first titration lab, anytime you're doing a titration, you want to make sure your burette is clean and all your reaction flasks are clean and dry. So I've already rinsed this with distilled water and with the solution that I'm going to be using, which is the silver nitrate. So this is already clean and ready to go. Remove my waste beaker, put my reaction flask underneath. I've already taken my initial reading for my burette readings. So now I'm just going to start the titration. Again, I'm going to turn it so that I can adjust the flow rate with my right hand and stir with my left hand. So again, when you're doing a titration, if you don't know how much volume it's going to take to reach your end point, you want to start by adding it very slowly, a drop at a time. So 1 drop. And I can already see right away I'm getting a little bit of that reddish color in the solution. So I'm going to continue at a very slow rate because I don't want to go over my end point. And if I'm seeing that reddish color already, it's probably not going to take a lot of silver nitrate to reach the end point. Okay, so we're getting very close to our end point here. You see how the red color or the orangish color is staying longer and longer with every drop. So I'm going to slow it down and just add one drop at a time. I think we are there, so I'm just going to take the distilled water, just give a rinse along the edges of the flask, so in case there's any silver nitrate there that may be up around the edges. I want that all rinsed down into the solution. Okay, there we go. So that's our end point. So you can see that the yellowish color of the chromate is gone. We're left with a brownish red color of the silver chloride, and you should be able to see that there's some solid particles in there. As I shake it, you can see it mixes up. So there's a precipitate in there. That's our silver chloride that's settled to the bottom. So that's our end point that we're looking for. So that's our first titration for our standardization. Now I'm going to do two more, and you're going to use those values for your standardization of the silver nitrate solution. And the next thing we're going to do is run an indicator blank. Okay, so now we're going to run an indicator blank. So an indicator blank or a titration blank is a sample that includes all the reagents we use except for the analyte itself. So we don't add any sodium chloride to this one, just the 50 milliliters of water and the 2 milliliters of the indicator. Okay, so there's no actual sodium chloride in this flask. So we're going to titrate that one. And indicator blanks usually don't require very much of the solution to change color. As you can see, it's one drop, and it's already almost completely turned red. So I'll just try one more drop. Go. So it's a little bit orange, but most of the red went away and it came back to yellow. So I'll try one more drop. There we go. And again, as I did before, I'm just going to rinse down the inside walls of the flask. There. And then you can see we have that reddish brown, almost an orange type color. So that's the color that we're looking for the end point. As you can see, it only took a couple drops. So the volume of that is just going to be probably about less than a mil, it looks like, by looking at the pipette. Okay, so that's going to be your volume you're going to use for your blank for this titration. So now that we have standardized our silver nitrate solution, we can move on and analyze our samples. So we're looking for the salinity content of our samples. So I have two samples here, A and B, so they're both saltwater solutions, but we don't know what the concentration of chlorine in them is. So we're going to do our titration now with our samples. So for our samples, we're going to use 10 milliliters of the sample. So we're using a volumetric pipette to get the 10 milliliters. And this has already been rinsed and cleaned. I should say cleaned and then rinsed. 10 milliliters into the flask. Okay. To that, I'm going to add the indicator, so the potassium chromate. Just a few drops this time. 3 drops. Okay. So I'm just going to remove my waste beaker, the flask in here ready to go. Record the initial volume. I just have a card I can hold behind it this time. Okay. And we can start our titration. So with these samples, because we don't know how much chlorine is in there, we don't know what the salinity is. Again, we want to start off slow, at a slow rate, just a couple drops at a time. And as we start to see some red color stick around, we can slow it down even more. So I'm getting a precipitate forming. Don't see any red color yet. So I can speed it up. starting to see some red color, so I'm going to slow it down, give it a stir. So now I know I'm close to the end point. Again, rinse out the flask, rinse off the tip of the burette. Make sure all the silver nitrate is down in the solution. And now I'm just going to do 1 drop at a time. And that looks like our end point. Just make sure it stays that color. Sometimes when you're doing titrations, as you mix it, the color fades away, so you may need to add 1 drop or even half a drop. It looks like our color is staying here now. So we've reached our end point for our first unknown sample, sample A. So we'll record that value, and now we're going to move on to sample B. Now we're ready to do sample B. So sample B, again, another saltwater solution. So I have the 10 milliliters of sample B plus the 3 drops of the indicator already measured out. So we can start our titration. Our initial reading has been taken. Again, when we don't know how much salinity we have, we start off fairly slow. When we start to see any sign of the red, we can slow down. So the red color is starting to stay around, so I'm getting near my end point. So I'm just doing it dropwise. And as I swirl, you can see it goes away again. 1 more drop. One more. There we go. Rinse down our size of our flask again. There. Our endpoint color has been reached. So we'll record those values for sample B. You can use those values along with the concentration of silver nitrate that you calculated from your standardization procedure. And you can use that information to calculate the percent salinity in your unknown samples. Thanks for watching. We'll see you in the next lab.